Hi everyone, jumping right in, today I want to show you how to work with SVG vector images in SwiftUI. But before diving into details, let me first show you the final result we're going to achieve in this video. As you can see, we'll be building a simple quiz style app where the user is asked to tap on specific parts of a bike. When they interact with the image and select the correct part, it will be highlighted, and a new question will be generated asking for a different bike component. The first thing we need is an actual SVG image. I found that going to the FreePic website, filtering by vector type and using specific keywords in the search gives some really high quality SVGs. That's exactly where we'll be grabbing our bike image from this project. After downloading the SVG file, you can open it with a text editor and you'll see a lot of numbers, paths and what might look like random text. This is actually the underlying structure of an SVG, just a set of points and paths forming up shapes. But as you might notice, it's not easy to tell which part of the bike corresponds to which path just by looking at this raw code. And this is where an awesome tool like Figma really shines. By importing the SVG directly into Figma, we get a clear visual breakdown of each path and how it maps to specific parts of the bike. To make sure we're selecting the right component, we can click multiple times on a part until we drill down to the vector level on the left sidebar right here. Once there, we can rename that vector path with a custom label, something meaningful that we'll later use in our SwiftUI code to identify and interact with the specific part. In our case, the saddle, the down tube, the fork, the wheel, and so on and so forth. After renaming all the components, select the entire group and go to Export Settings. Choose SVG as the format, and now pay attention, click the three dots and make sure the Include ID attribute is checked. These IDs let your SwiftUI code target specific bike parts. Now just click Export and save it wherever you want. Now open the exported SVG in a text editor and search for something like saddle, in our case. You should see an ID equals saddle linked to a path. That confirms everything was set up correctly in Figma. Once verified, we can import that SVG into our Xcode project. Just double check that all your custom IDs from Figma are present in the SVG code. Next, create a standard iOS app project in Xcode. Enter your desired project name and keep the rest of the settings as they are. Save it wherever is convenient for you. Now let me show you how to import the SPM package we'll be using in this video. It's called SVG View, and I've included the link in the description below. While the documentation is a bit minimal here, we'll go beyond the basic examples provided. Essentially what you want to do is copy the GitHub repo URL from their page. In Xcode, go to File, Add Packages, paste that URL, and then click Add Package, and we're all set. Next, I'll create a new folder called Resources and drag in the SVG file we just exported from Figma. The first part of the UI will be a simple button used to reset the drawing paths. I'll place it inside an H stack with a spacer for alignment. Then, for better readability and cleaner code, I'll extract the button into a separate view. I like to emphasize writing clean and maintainable code, so I'll follow this approach for each UI component. Next, I'll add the bike view to the layout, but for now, I'll just use a rectangle with a set frame as a placeholder. Next, I'll add the text section where the quiz question will be shown, something like tap on the saddle. I'll position it just below the bike view placeholder, give it a slightly larger font for visibility, and add a bit of padding, and of course center it nicely so it's easy to read. Now I want to control the quiz question text. If there are no more questions left for the user, we should display a message like quiz over, well done. To handle that, we can use a state boolean variable and update the text based on its value. If you remember from Figma, we had to rename each bike part we want to control in code by assigning it a specific name or ID. To make things easier in Swift, we'll use an enum to represent each part we want to interact with. This helps us avoid using raw strings throughout the code, keeping things cleaner and less error-prone. You can grab the enum directly from my GitHub repo if you'd rather not write it out yourself. Just make sure the cases match the IDs you set in your own SVG file. To make things even smoother, we can add computed properties to our enum, one for returning the right color based on each case, and another for providing a user-friendly display name for the quiz question. This way, all the logic stays organized within the enum, making the code cleaner and easier to maintain. Now getting back to our bike view, let's implement it. We'll loop through all the enum cases, and for each one, we'll attach an on-tap gesture to its corresponding SVG node using the ID. When tapped, we'll trigger a function that handles the logic, checking if the tapped part matches the current quiz question, coloring the correct part if it does, and then generating a new random question. This keeps the interactivity smooth and dynamic. We'll also need to create the SVG view as a state property. This ensures that the view maintains its state across updates, so when a user taps a part of the image, it stays highlighted and doesn't get redrawn or reset when SwiftUI re-renders the view. This is key for preserving the interaction and visual feedback throughout the quiz flow. You can declare it at the struct level, or like I do, make it optional and only initialize it on the onAppear modifier, if the URL is valid. This way, you avoid unnecessary loading and ensure the view is set up only when the resource is ready. Besides our enum, we also need another struct that's hashable and contains a bike part of the enum type, along with the bike shape of the type SVG shape. This allows us to keep track of which shapes the user has tapped, so that when we want to reset the colors, we know exactly which shapes to revert. Now let's get our UI back in action by implementing this fieldBikePart function. We'll pass a bikeconfig struct to it, and once that's set up, our preview should render correctly again. However, keep in mind there's still no interaction wired up just yet. That's coming up next. Of course, we also need a state variable of our bikePart enum type to keep track of the current correct answer for the quiz at any given moment in time. Additionally, we'll use a set to store the parts that have already been tapped by the user. The reason we go with a set is its uniqueness feature. No matter how many times the user taps the same shape, it will only be recorded once. Alright, let's wrap up the fieldBikePart logic. It's pretty straightforward. First, we check if the user tapped the correct bike part by comparing it to the current quiz question. If it's a match, we fill that part with a color. Then, we insert that part into our tapped parts set. Next, we map the tapped bikeconfigs array, which holds both the enum and the shape, to get just the enum values. Using that, we filter out the remaining parts by subtracting the tapped ones from the all cases of our enum. This ensures the next question is always a new untapped part that the user hasn't seen yet. Finally, if there are no more parts left, we update our quiz state that we implemented before, and we update it with true. This way we mark our quiz as complete, and that text question will update with our message quiz over, well done. We forgot to update the quiz question text to reflect the currently selected bike part. Using that variable, we can easily change the question to match the component the user needs to tap. So below the quiz over well done, we should update the click on the saddle with click on D, then use our state variable current bike component display name, which is a computed property used to help us access faster the string related to that bike part. Everything works smoothly, I say. We can now tap each bike component that we set up in Figma, and the interactions behave as expected. Now one thing left to do is to implement that reset button that we first implemented in our UI, so we can let the user start fresh once everything is completed. We just need to take a few simple steps to fully reset the quiz, loop through all tapped parts and reset their color back to white just like at the start. Set is quiz over back to false so the app knows the quiz should run again. Reset current bike component to saddle so the first question is always consistent. And last but not least, clear out the tap parts set to remove all previously selected parts. That's it, the quiz is now fully reset and ready to go again. I really hope you picked up something useful from this video. This approach is super versatile. In fact, many coloring apps you see on the App Store use a similar technique. You can also apply it to things like geography quizzes using an SVG map of the United States, for example, identifying car parts, or really any labeled illustration. If you'd like to see a follow-up, maybe something where parts of the image move when the user taps or slides, drop a comment below and let me know. As always, happy scribbling and see you in the next one.